Hello, and welcome. I am grateful you have joined me tonight. Before us lies a question shaped not by folklore or fantasy, but by silence. Antarctica, a continent we imagine as empty, white, and unchanging. Yet beneath its ice, deeper than even our most powerful instruments have fully reached, waits a story that stretches far beyond human memory. Antarctica is the coldest, driest, most remote place on Earth. Its winds howl across open plains of snow. Its ice lies stacked in layers miles thick, older than entire civilizations, older than much of recorded history itself. To stand on its surface is to stand on a library of time, though one written in frozen pages that require careful reading. And as with any library, some volumes are missing, others buried, and still others erased. What draws us to this continent is not only its silence, but also its secrecy. What lies beneath the glaciers? What stories of Earth's past are hidden in mountains never seen by human eyes? What fossils sleep in the dark, pressed into stone beneath kilometers of ice? When we think of ancient civilizations, we think of deserts and ruins, jungles and lost cities. Rarely do we imagine a place of endless cold. And yet, if Earth has ever wished to hide its oldest chapters, it could do no better than this continent at the bottom of the world. Pause for a moment and picture it. A continent twice the size of Australia, locked beneath ice so heavy it presses down the land itself, carving valleys, burying mountains, sealing away rivers. Satellites peer through with radar and reveal ranges as tall as the Alps. They show hidden lakes, some larger than entire countries, sealed in darkness for millions of years. Even with modern technology, Antarctica keeps its secrets close. For a long time, we imagined it had always been like this. Eternal ice, eternal silence, but the rocks tell another story. Fossils of tree ferns, of cycads, of ancient reptiles have been found in places now barren and frozen. Trunks of trees once reached skyward, where glaciers now grind across stone. At one time, forests stretched across Antarctica's landmass, nourished by a climate warm enough to support rivers and rain. Dinosaurs once walked its soil. Later, in warmer epochs, temperate forests thrived again. This shift is a reminder that continents move, climates change, and what seems permanent is often temporary. Antarctica was once part of Gondwana, a vast supercontinent. It lay in milder latitudes, connected to Africa, India, and South America. Life flourished there, unaware of the icy fate awaiting it. Over millions of years, Antarctica drifted southward. Ocean currents shifted, climate cooled, ice advanced. Eventually, forests gave way to glaciers and rivers to frozen deserts. What remains today is only the final stage of a very long transformation. And this is where the subtle mystery begins. Earth forgets, it erases. Ice is both preserver and destroyer. It can seal air in bubbles for 1 million years, offering us precious records of ancient atmospheres. But it can also grind entire landscapes into dust, scattering evidence and burying histories. If a forest can vanish so completely, if dinosaurs can leave only faint traces beneath rock, what else could have been lost? What other stories might lie hidden, erased by cold and time? Imagine for a moment a city built of stone. Leave it untouched for 1,000 years, and nature begins to reclaim it. For 10,000, and it crumbles. For 1 million, it is gone, reduced to dust, buried beneath shifting soil. If human works cannot survive 1 million years, what could survive tens of millions beneath glaciers? This is not a claim that civilizations once thrived in Antarctica. It is simply a reflection on how fragile evidence can be, and how perfect a place Antarctica is for forgetting. It is here, after considering this vast silence, that I invite you gently. If you find yourself curious, if you are soothed by this pace and intrigued by these questions, you are welcome to subscribe or leave a note of where and when you are listening from. It helps this story reach others who may also seek a quiet exploration of Earth's hidden histories. There is no rush, only an invitation, like a small light left in a window, guiding you back when you choose. Now, let us return to the ice. Scientists studying Antarctica peer through it using radar and seismic waves. They see valleys carved by rivers no longer flowing. They find mountains untouched by sun or wind for millions of years. They discover subglacial lakes such as Lake Vostok, sealed away in perfect darkness, larger than many known freshwater bodies. These lakes are cut off from the world above, yet they may still harbor microbial life, adapted to pressure, cold, and silence. The thought is humbling. Life can survive where we least expect it. If microbes endure beneath ice, if forests once thrived in polar latitudes, what range of possibilities has Earth held across its history? Not every possibility leaves a clear trace. Most vanish, folded back into the planet's cycles. Fossils are rare, artifacts rarer still. Whole landscapes rise, fall, and are forgotten as the winds continue to sweep across Antarctica today. Carrying snow that may never fully melt, we are left with the sense that this continent is both a beginning and an end. A beginning because it preserves some of the earliest records of Earth's climate, and an end because it erases so much of what came before. Standing at the edge of such a place, we cannot help but wonder how many stories sleep still beneath its white silence. Antarctica is not only ice, it is a mirror. It reflects back to us the fragility of evidence, the impermanence of memory, and the immense timescales that shape this planet. What we see on its frozen surface is only the latest page in a book billions of years old. Most of the earlier pages have been sealed shut, waiting in darkness. Perhaps they will never be opened. Or perhaps one day, through careful study and quiet patience, we will learn to read more of what lies beneath. Imagine, for a moment, Antarctica not as a frozen wasteland, but as a land alive with green. A place where forests stretched for miles, where rivers meandered gently through valleys, where the air was rich with the scent of vegetation and the quiet hum of life. It is difficult to picture now, but rocks and fossils insist that such a world existed. Petrified wood, fossilized pollen, and the remains of ancient plants speak to an Antarctica far warmer, far more hospitable than the ice-bound continent we know today. Millions of years ago, Antarctica was not alone. It was part of Gondwana, a massive supercontinent that tied together what would become Africa, South America, India, Australia, and Antarctica. From the warmth of tropical latitudes to polar fringes, Gondwana hosted ecosystems of unimaginable variety. In its southern reaches, where Antarctica now lies, temperatures were mild, climates temperate, and forests thrived. Dinosaurs roamed, insects swarmed, and plants reached heights that dwarf our modern trees. Evidence of these forests emerges from the rocks themselves. In the Transantarctic mountains, for example, fossilized tree ferns and cycads stand upright, frozen in stone. Some are nearly complete, their trunks preserved in remarkable detail. Pollen grains, tiny and resilient, have been discovered in sediments that are millions of years old. They tell us not only about the plants that once grew, but also about the climates that supported them. The air was warmer, rainfall patterns different, and sunlight sufficient for life to flourish. Reconstructing this ancient world requires careful attention. Antarctica's modern ice sheets obscure nearly every trace of what once existed. Mountains are buried, valleys are filled, rivers are frozen or vanished. The land has drifted south over millions of years, pulled by the slow churn of tectonic plates. As Antarctica moved, ocean currents shifted, climate patterns changed. The warmth that nurtured forests gave way to colder temperatures, and eventually, ice began to dominate. The onset of glaciation was gradual at first. A few patches of permanent ice appeared, retreating and advancing with minor climate fluctuations. But over millions of years, the ice sheets thickened. Glaciers expanded outward, reshaping the surface of the land. Valleys were carved, mountains smoothed, rivers buried. Entire ecosystems disappeared under kilometers of ice. In some ways, this process was selective preservation. Fossils trapped in rock survived. Sediments beneath frozen lakes remained intact. Yet so much more was erased, wood rotted before fossilizing. Soft-bodied creatures disappeared entirely. Evidence was lost to pressure, grinding, and movement. Even in modern times, scientists are still piecing together this history. Fossilized plants are rare, but each discovery is remarkable. They are reminders that what we see today, ice, snow, silences only the most recent layer of a very long story. The contrast between what was and what is can feel almost unimaginable. Rivers that once ran freely are now buried. Forests that stretched for miles are now hidden beneath ice or reduced to microscopic traces. Antarctica's memory is partial, selective, and often hidden in plain sight. This process of erasure and preservation is central to understanding the continent. Ice is both archivist and destroyer. It preserves chemical signatures in layers of ice cores, capturing atmospheres from hundreds of thousands of years ago. Tiny bubbles of air sealed within these cores reveal carbon dioxide levels, methane concentrations, and other clues to the planet's climate history. Yet ice also scrapes, grinds, and shifts. Valleys are filled, mountains are reshaped. Evidence of ecosystems and even entire landscapes may vanish, leaving only subtle hints beneath kilometers of frozen stone. One of the most striking elements of Antarctica's hidden past is the existence of subglacial lakes. Sealed beneath ice for millions of years, these lakes contain water that has never seen sunlight. Lake Vostok is the most famous, but dozens more exist, some still undiscovered. In these lakes, microbial life persists, surviving extreme cold, pressure, and darkness. They are examples of resilience, life enduring in isolation, and they hint at the kinds of ecosystems that might survive in places humans cannot easily reach. Beyond lakes, Antarctica conceals entire mountain ranges. The Gambitsarv Mountains, taller than the Alps, are completely buried under ice. Radar imaging reveals their peaks and valleys, their contours shaped long before glaciers arrived. These mountains remind us that beneath the surface lies a world that has existed for millions of years, largely hidden from view. Glaciers slide over them, reshaping and smoothing, yet leaving enough for scientists to detect their presence. The slow movement of ice is both destructive and preservative. Glaciers carve valleys and shape mountains, but they also protect what lies beneath. Sediments, fossils, and even microbial life are shielded from wind, temperature changes, and exposure. In this way, Antarctica holds both evidence and mystery. It is a continent of contrasts, frozen yet alive, silent yet dynamic, erasing yet preserving. As we reflect on this ancient world, consider the scale of time. Forests that vanished tens of millions of years ago, barely remembered except for fragments. Rivers and lakes disappeared without leaving more than subtle geological signatures. If human activity cannot survive even a fraction of this time without leaving traces, imagine how complete the erasure can be in a place like Antarctica. The continent itself becomes a symbol of impermanence and continuity, a place where life, geology, and ice interact over unimaginable spans. Even the fossil record we have is patchy. Soft-bodied organisms rarely fossilize. Wood and leaves decompose quickly unless conditions are perfect. What survives is often fragmentary, leaving scientists to reconstruct ancient worlds from pieces scattered across rock and ice. Antarctica's fossil record, therefore, represents only a fraction of what once existed. Every discovery, every preserved specimen, is extraordinary not only for what it tells us, but for what it suggests might have been lost entirely. The continent's drift, glaciation, and climate change also illustrate how fragile ecosystems are. Life adapts, migrates, or dies. Forests turn to fossils. Dinosaurs vanish. Microbes endure in isolated lakes. Antarctica teaches patience, observation, and humility. It shows that even the grandest and most visible forms of life can disappear, leaving subtle whispers for those willing to look. And here we return to a quiet question. If Antarctica's ice can erase forests, rivers, and entire ecosystems, what else might it conceal beneath its frozen surface? The answer is unknowable, yet it stirs imagination. We know the continent preserves some records, fossils, sediments, ice cores. We know much more has likely been lost. This interplay of preservation and erasure is central to Antarctica's mystery. It is not a question of fantasy, but of scale, time, and the planet's remarkable ability to both protect and forget. The story of Antarctica's drift and changing climate is also a story of the Earth itself. Continents move, oceans shift, climates fluctuate. Ice advances and retreats, ecosystems emerge and vanish. Life adapts or is extinguished. Evidence is preserved only where conditions allow, and even then, only partially. Antarctica is a profound example of this dynamic, a continent shaped by forces that act slowly but relentlessly over millions of years. As we continue this exploration, it is worth remembering that every fossil, every hidden valley, every subglacial lake offers a window into this past. Even if we cannot see it directly, the continent speaks through the work of scientists, through careful measurement, and through patient reconstruction. Antarctica is alive with history, even if that life is buried, frozen, or concealed beneath ice. We end this part with a reflection on scale and patience. Antarctica's story reminds us that the planet operates on timelines far longer than human perception. Forests vanish, mountains rise and crumble, ice sheets wax and wane. Life persists where it can, but much is lost. The silence we experience today is not emptiness, but the echo of eons. Hidden beneath ice, beneath kilometers of frozen stone, lie fragments of worlds long gone. They are preserved, yet erased, visible, yet concealed, waiting for patient eyes to interpret what remains. Beneath Antarctica's seemingly endless ice, there exists a hidden world, unseen by human eyes, yet revealed through careful observation. This world is composed of lakes, sealed for millions of years, mountains entirely buried under ice, and rivers flowing quietly beneath glaciers. To contemplate it is to stretch the imagination while remaining grounded in science. Every discovery tells a story of resilience, endurance, and the extraordinary ways the planet preserves and conceals. Among the most remarkable of these hidden features is Lake Vostok. Buried beneath more than 2 miles of ice, it is one of the largest subglacial lakes on Earth. Its waters have never touched sunlight, never felt wind or rain, yet life persists there. Microbes have been found in these extreme conditions, organisms adapted to pressure, cold, and complete darkness. Their existence demonstrates the remarkable adaptability of life and offers insight into how ecosystems can endure in isolation, cut off from the rest of the world for millions of years. Lake Vostok is not unique. Scientists have identified hundreds of subglacial lakes scattered across Antarctica. Some are small, others vast. Some have been sealed for millions of years, and some are connected by hidden rivers flowing silently beneath the ice. These lakes represent ecosystems untouched by humans, untouched by the atmosphere above, and in some ways, untouched by time as we perceive it. Yet their isolation also means they are frozen archives, preserving chemical and biological evidence of a long-forgotten past. In addition to lakes, Antarctica conceals entire mountain ranges beneath its ice sheets. The Gambutsov Mountains, taller than the Alps, remain completely hidden from view. Their peaks and valleys are traced through radar imaging, revealing the contours of a landscape that existed long before glaciers spread across the continent. These mountains are remnants of a world far older than humans, sculpted by tectonic forces, erosion, and the slow, patient shaping of Earth over hundreds of millions of years. Glaciers move across these mountains with steady, quiet force. Ice sheets grind rock into powder, carving valleys and smoothing peaks. In this way, the continent both preserves and erases. Sediments and fossils are protected beneath kilometers of ice, yet other evidence is destroyed through relentless motion. Mountains that have stood for millions of years are slowly reshaped, their history both preserved in part and concealed in part. Antarctica is both archive and eraser, revealing fragments while hiding the whole. Seismic studies and ice-penetrating radar have revolutionized our understanding of these hidden landscapes. Scientists measure the thickness of ice sheets, detect subglacial rivers, and map the contours of mountains that have never felt sunlight. Each finding is a testament to the ingenuity and patience required to study a continent so extreme, so distant, and yet so essential for understanding Earth's history. Through these methods, valleys carved by ancient rivers are revealed, lakes isolated for eons are mapped, and evidence of past climates is uncovered. These discoveries also remind us of the scale of time and change. Valleys that were once carved by flowing water are now filled with ice. Rivers that nourished forests are gone, leaving only subtle geological hints. Forests that thrived under temperate climates are reduced to fossilized fragments, waiting in stone for careful observation. Ice sheets advance and retreat, subtly reshaping the surface. Antarctica is a living record of endurance, change, and the persistent interplay between preservation and destruction. The hidden lakes and mountains also offer insight into life in extreme conditions. Lake Vostok and its neighbors contain microorganisms that survive without sunlight, deriving energy from chemical reactions with minerals in the water and sediments. These ecosystems may provide clues to how life can exist in seemingly inhospitable environments elsewhere on Earth, and perhaps even on other planets. They are reminders that resilience is a defining feature of life, even in places humans might never tread. In considering these hidden features, one cannot ignore the subtle mystery of erasure. Ice preserves some evidence while obliterating other traces. Forests, rivers, and landscapes that once existed have largely vanished. Fossils are fragmented. Sediments are buried deep beneath kilometers of frozen stone. The contrast between preservation and destruction is profound. Antarctica keeps its secrets carefully, revealing them only in fragments to those who seek patiently and observe with care. Imagine standing at the edge of a subglacial lake. Above, kilometers of ice press down silently. Below, water moves in darkness, carrying sediments that have been undisturbed for millions of years. Mountains rise beneath the ice, their jagged peaks folded and sculpted by ancient tectonic forces. Rivers flow where no one can see. Life persists where no one can touch. It is a world that exists beyond our direct perception, yet it is real, measurable, and astonishing in its quiet complexity. These hidden landscapes also remind us of the limits of human observation. Much of what exists beneath Antarctica will likely never be seen directly. We rely on instruments, measurements, and indirect evidence to reconstruct this world. Ice cores provide chemical records. Radar reveals valleys and mountains. Microbes tell stories of isolation and survival. Each method offers only a partial view, yet together they sketch a picture of a continent alive with hidden processes, ancient history, and enduring mystery. The interplay of preservation and erasure is central to understanding Antarctica. Ice both protects and destroys. Sediments in lakes may remain untouched for millions of years, yet forests and rivers are buried or obliterated. Fossils may survive in fragments, while entire ecosystems vanish. Antarctica is a study in contrasts, frozen yet alive, silent yet dynamic, concealing yet revealing. It teaches patience, observation, and humility in the face of processes far larger than human lifetimes. Reflecting on this hidden world, it is tempting to wonder what else lies beneath the ice. Valleys, lakes, mountain ranges, and rivers are visible through instruments, yet much remains beyond detection. The continent's transformation over millions of years suggests that other traces of ancient landscapes, perhaps even of life we have not yet imagined, could remain hidden. The scale of erasure and preservation in Antarctica is unlike anywhere else on Earth, offering a unique laboratory for understanding history, geology, and life in extreme conditions. Antarctica's glaciers, hidden lakes, and mountains also reveal the importance of perspective. What seems empty and lifeless at first glance is in fact dynamic and complex. Ice moves slowly, yet relentlessly, shaping the land and influencing global climate patterns. Subglacial lakes persist, harboring life. Hidden mountains shape ice flow and weather patterns. Every feature has its story, contributing to a larger understanding of the continent and its place in Earth's history. Even the act of discovery is measured and patient. Scientists working in Antarctica endure extreme cold, isolation, and logistical challenges. Drilling through kilometers of ice takes months, sometimes years. Radar surveys require careful interpretation. Ice cores must be handled delicately to prevent contamination. Every finding is the result of meticulous work, patience, and an understanding of processes that operate on scales far beyond human perception. Through these efforts, Antarctica slowly reveals its secrets. Subglacial rivers trace hidden paths beneath glaciers. Lakes preserve life in isolation. Mountains tell stories of tectonic forces and ancient landscapes. Sediments contain chemical records of climates long past. Each discovery is a window into a world that exists largely out of reach, yet remains profoundly connected to the story of Earth as a whole. This hidden continent is also a reminder of impermanence. Forests, rivers, and ecosystems that once thrived have vanished. Icy races as much as it preserves. Even mountains, grand and enduring, are shaped and reshaped by glaciers. The evidence of life and climate is fragmented, leaving scientists to reconstruct history from pieces. In this way, Antarctica embodies the delicate balance between memory and forgetting, preservation and erasure. And so, as we contemplate these hidden lakes, mountains, and rivers, we are reminded that Antarctica is both ancient and ever-changing. Its secrets are buried beneath ice, yet accessible through patient study. Its history is recorded in sediments, fossils, and chemical signatures. Its landscapes have transformed dramatically over millions of years. The continent challenges assumptions about permanence and reminds us of the vast timescales on which Earth operates. In this quiet reflection, one can sense the power of Antarctica not only as a physical place, but as a symbol of endurance, mystery, and the delicate traces that survive when most is lost. Ice preserves, yet erases. Mountains rise, yet are reshaped. Lakes harbor life, yet remain hidden. Fossils speak, yet are incomplete. The continent is alive with evidence of a past far older than human memory, and it invites contemplation of what has been, what endures, and what may never be seen. Beneath the glaciers and ice sheets of Antarctica, the remnants of long-lost worlds sleep quietly in stone and sediment. Fossils, preserved with patience and resilience, are delicate windows into the continent's past. They tell of forests that once stretched across valleys, of rivers that nurtured life, and of creatures that roamed a land far warmer than the ice-covered plains we see today. In these remains, we find not only evidence of life, but also the profound impermanence of memory. Consider the Transantarctic mountains, where fossilized wood and plant remains are still upright, locked in the rock. Some trunks have retained remarkable detail, their textures preserved across millions of years. Each piece of wood, each leaf imprint, speaks of forests that existed before the first ice sheets covered the continent. These fossils are fragments of a larger story, hints of ecosystems that thrived under temperate climates, nourished by abundant rainfall and sunlight. Fossils in Antarctica are rare and precious because the conditions required for preservation are extraordinary. Wood and soft tissues decay quickly under normal circumstances. Only through rapid burial, mineralization, and protection from erosion can these traces survive the millennia. That so many have endured beneath Antarctic sediments is a reminder of how fragile yet persistent memory can be, preserved in unexpected places, while countless other traces vanish entirely. Ancient pollen grains, tiny yet resilient, have also been discovered embedded in sediment layers. They reveal the presence of ferns, conifers, and flowering plants long extinct in the region. Pollen is like a whisper from the past. Each grain carries chemical and structural information about the environment in which it once thrived. By studying these grains, scientists reconstruct the climate and ecosystems that supported life, painting a picture of Antarctica as a vibrant, living continent rather than a frozen desert. Fossils also tell us about the creatures that once inhabited Antarctica. Dinosaurs, for instance, roamed its forests and river valleys during the Jurassic and Cretaceous periods. Fossils of Cryolophosaurus, a large predator, and other reptiles provide evidence that life thrived far from the icy conditions we associate with the modern continent. Amphibians and early mammals, may have lived there as well, adapting to climates that shifted gradually over millions of years. The fossil record, though incomplete, offers tantalizing glimpses into these ancient worlds. The contrast between what existed and what survives today is striking. Rivers, forests, and lakes have vanished beneath kilometers of ice. Sediments have shifted, mountains have been reshaped by glaciers, and soft-bodied organisms have left little trace. Fossils are fragments of ecosystems that no longer exist. Their survival depends on both chance and circumstance, reminding us that memory is selective, and that time acts as both preserver and destroyer. Antarctica's ice is central to this delicate balance. Glaciers grind and scrape the land, erasing some evidence while shielding other records. Ice cores preserve chemical traces of ancient atmospheres, capturing carbon dioxide and methane levels from hundreds of thousands of years ago. Yet glaciers also move, reshaping valleys and crushing rocks. The processes that protect life in one form can simultaneously erase it in another. The continent is a landscape of contrasts, evidence preserved, yet also continually destroyed. Subglacial lakes, too, play a role in preserving ancient life. Lakes such as Vostok and its hidden neighbors contain sediments and water untouched by sunlight for millions of years. Microbial life persists, isolated from the modern world. These lakes offer a rare glimpse into the persistence of life in extreme conditions, a reminder that even beneath ice, biology endures. They are living fossils, evidence that life can adapt, survive, and flourish in isolation over geological timescales. The Gambardsav Mountains, hidden entirely beneath ice, also contain fossils and sediments that speak of Antarctica's warmer past. Mountains and valleys that existed before glaciation were home to forests and rivers. As ice advanced, some evidence was buried and preserved, while other traces were ground into sediment or carried away by glacial flow. Each discovery in these mountains adds to the understanding of how ecosystems survived, transformed, and disappeared under the relentless advance of ice. Reflecting on these hidden ecosystems, one begins to appreciate the magnitude of Antarctica's story. Life here has endured extraordinary transformations, drifting continents, shifting climates, advancing ice sheets, and changing ecosystems. The fossils and sediments preserved beneath the ice are fragments of this story, reminders that the past is vast, intricate, and often hidden. Antarctica is not silent, it speaks in subtle, quiet ways to those willing to listen. Consider the implications of what has vanished. Entire forests, rivers, and ecosystems once thrived where ice now dominates. Creatures that lived, hunted, and reproduced left only traces, fragments in stone, pollen, and chemical signatures. Evidence is fleeting. What survives depends on circumstances, geology, and the slow march of time. In Antarctica, preservation and erasure are entwined. The continent holds memory, yet conceals it, offering glimpses into what has been while obscuring most of the rest. This interplay between preservation and loss extends to the ways scientists study the continent. Radar imaging and seismic studies reveal hidden mountains and valleys. Ice cores capture chemical signatures, sediments preserve fossils and pollen. Each method uncovers a fraction of Antarctica's story, but always through indirect observation. The continent cannot be fully revealed. Its secrets emerge slowly, patiently, over decades of careful study. And so the question lingers, quietly, if life, rivers, forests, and entire ecosystems could vanish beneath ice, leaving only fragments, what else might remain hidden? The answer is unknowable, yet the question itself is profound. Antarctica is a continent that erases and preserves with equal power. It teaches humility in the face of time and patience in the pursuit of knowledge. What is gone, yet fragments endure, waiting to be discovered, interpreted, and understood. As we contemplate these fossils and hidden ecosystems, we are reminded of the immense scale of geological time. Forests that vanished millions of years ago survive only as traces. Life that existed under warmer skies is now obscured beneath ice. Antarctica's ice sheets advance and retreat slowly, yet their effects are transformative. Every valley, every subglacial lake, every buried mountain contributes to a story of both survival and erasure. This reflection also offers perspective on Earth as a whole. The planet is dynamic, constantly reshaping landscapes, climates, and ecosystems. What appears permanent is often transient. Evidence of life and complexity is fragile. Antarctica is a vivid reminder of this impermanence. It preserves, yet destroys. It reveals, yet conceals. It is a place of both history and mystery, where patience, observation, and reverence for time are required to glimpse what once was. In this quiet contemplation, one begins to understand the rhythm of Antarctica, the slow movement of glaciers, the advance and retreat of ice, the entrance of life in isolated lakes, the preservation of fossils, and the erasure of entire ecosystems. The continent's story unfolds not in bold declarations, but in subtle clues, patient measurements, and fragments of memory buried in stone, ice, and water. Antarctica is therefore both a challenge and an invitation. It challenges our assumptions about permanence and evidence, reminding us that life and history can be erased or hidden entirely. Yet it invites curiosity, contemplation, and discovery. Each fossil, each pollen grain, each subglacial lake is a thread connecting us to a past far older than human memory. They remind us that what lies beneath the ice is vast, intricate, and waiting to be slowly understood. As we move forward from fossils to the broader landscapes that once hosted life, it is important to carry this sense of patience and humility. Antarctica is not a place that yields its secrets easily. Every discovery requires careful attention, meticulous work, and an understanding of processes operating over millions of years. The continent teaches that the pursuit of knowledge is gradual, and that the most extraordinary stories may be hidden in the quietest, most inaccessible places. And so, the ghosts of ancient ecosystems linger beneath the ice. They whisper of forests, rivers, and life that existed long before humans walked the earth. They remind us that preservation is delicate, erasure inevitable, and evidence rare. Antarctica is both archive and erasure, concealment and revelation. In contemplating these hidden ecosystems, we learn to appreciate the vast scale of time, the fragility of memory, and the quiet persistence of life. Antarctica's ice is more than a frozen expanse. It is a living archive, recording the whispers of climates long past, the subtle traces of atmospheres that have changed over millions of years, and the delicate fingerprints of life that once existed. Each layer of ice is a page in a chronicle of deep time, a record written in snow, pressure, and cold, patiently accumulated over epochs. Ice cores, drilled with precision and care, reveal these chronicles. Each layer represents a year, or even a season, frozen and preserved. Tiny bubbles of air, trapped as snow compacts into ice, contain snapshots of the atmosphere at that moment in history. Scientists extract these bubbles to measure carbon dioxide, methane, and other gases, offering insight into Earth's climate cycles. These records stretch back hundreds of thousands of years, providing an unparalleled window into the rhythm of ice ages, interglacial periods, and shifts in global climate. The precision of this preservation is astonishing. Snow that fell centuries ago has compressed into dense ice, layered carefully beneath newer snowfalls. Each layer tells a story of temperature, of wind, of volcanic activity, and of biological activity. Chemical signatures, from isotopes to trace elements, reveal patterns invisible to the naked eye. Through meticulous analysis, we can read the rise and fall of greenhouse gases, the trace impact of distant volcanic eruptions, and even shifts in ocean currents. Antarctica's ice, in this sense, becomes a time machine, offering clarity on processes that span hundreds of millennia. Yet the ice does more than preserve the atmosphere. It also encases particles from continents far away. Dust, pollen, volcanic ash, and microscopic life are swept into storms and deposited in the snow. These particles provide additional evidence of ancient climates, helping reconstruct wind patterns, vegetation, and environmental change. A grain of dust trapped in ice may have traveled thousands of miles before settling, carrying a story of forests, deserts, or oceans long vanished. In this way, the continent links itself to the broader Earth, connecting its frozen silence to global processes. Antarctica's ice also tells a story of resilience. Glaciers move slowly but inexorably, grinding against bedrock, carving valleys, and reshaping landscapes. The weight of ice presses down, compacting older layers and preserving them beneath newer snowfalls. Subglacial lakes remain sealed, shielded from surface fluctuations. Life, when it exists in these hidden pockets, endures in isolation, adapting to darkness, pressure, and cold. Microbes in these lakes offer a glimpse of persistence, survival against odds that would seem insurmountable in other contexts. The study of ice cores also illuminates the interplay between preservation and erasure. Just as glaciers grind valleys and smooth mountains, ice both protects and conceals. Fossils, sediments, and chemical signatures are preserved beneath kilometers of frozen water. At the same time, evidence of ancient ecosystems on the surface may vanish, erased by the relentless movement of ice. The continent is a balance between memory and forgetting, a place where fragments endure even as much is lost. One of the most remarkable aspects of Antarctic ice is its ability to record sudden changes alongside long-term trends. Volcanic eruptions, for instance, leave layers enriched with ash and sulfur compounds. Massive climatic shifts appear in isotopic ratios of oxygen and hydrogen. These abrupt markers, preserved alongside gradual changes, offer insight into the forces that shaped not only Antarctica, but the entire planet. In this way, the ice becomes a dialogue between the slow passage of time and sudden, transformative events. The preservation within ice cores is extraordinary, yet also fragile. Careful drilling is required to avoid contamination. Once extracted, cores must be stored under controlled conditions, often at temperatures far below freezing. Even the smallest lapse can alter the delicate chemical balance, erasing information preserved for hundreds of thousands of years. Handling these cores requires patience and respect, a recognition of the deep time they contain and the delicate balance that has allowed them to survive. In addition to chemical and atmospheric records, ice also preserves biological material. Microbes, pollen, and even microscopic fragments of plant and animal life are trapped within layers. These remnants provide insight into how ecosystems responded to climate change, how life migrated or adapted, and how isolated pockets of organisms persisted under extreme conditions. Life's traces in ice are subtle, yet they speak volumes about resilience, adaptation, and the continuity of biology in a world dominated by glaciers. Beyond the ice itself, Antarctica's hidden mountains and subglacial lakes influence climate patterns globally. The Gambitsarv Mountains, for instance, affect the flow of ice sheets and the formation of subglacial rivers. These features, though concealed beneath kilometers of ice, have lasting effects on ice dynamics and, by extension, sea level and climate worldwide. Understanding these hidden landscapes is essential for interpreting ice core data, as the land beneath influences both preservation and movement of ice. Chemical signatures in ice cores also offer glimpses of life far beyond Antarctica. Dust carried from deserts, volcanic ash from distant eruptions, and pollen from other continents all leave subtle traces. These particles tell stories of wind patterns, climate shifts, and ecological change on a global scale. In this way, Antarctica becomes a mirror reflecting Earth's interconnected systems, revealing how the frozen continent is both isolated and deeply entwined with the broader planetary story. Reflecting on these discoveries, it becomes clear that Antarctica is more than ice and rock. It is an archive of history, a repository of life, and a laboratory for understanding the rhythms of Earth. Its preservation is remarkable, yet incomplete. Glaciers advance and retreat, erasing as much as they protect. Subglacial lakes preserve pockets of life, yet remain inaccessible. Fossils and sediments provide fragments, yet the larger ecosystems are lost to time. The continent reminds us that evidence is precious and fragile, that memory endures only under the right conditions, and that much remains hidden beneath the surface. Antarctica also teaches us patience. The processes recorded in ice cores unfold over tens of thousands, even hundreds of thousands of years. Glaciers move slowly, sediments accumulate gradually, and chemical changes occur over millennia. Scientific study mirrors these timescales, requiring careful measurement, repeated observation, and long-term monitoring. In contemplating Antarctica, one learns to align one's perception of time with the patient rhythms of the planet itself. The hidden complexity beneath ice sheets also prompts subtle wonder. What ecosystems existed before glaciation? How did ancient forests and rivers respond to shifts in climate and continental drift? What life persists in sealed lakes and hidden valleys? While the answers remain partial, the questions themselves are enough to inspire quiet curiosity. Antarctica is a continent of fragments and traces, of entrance and loss, of preservation and erasure. It invites reflection on the vast timescales over which life and geology operate. Through ice cores, scientists also explore Earth's climate system. They uncover periods of warming and cooling, abrupt shifts, and gradual trends. By analyzing isotopes, chemical signatures, and trapped gases, they reconstruct a planet in flux, responding to both internal processes and external forces. Antarctica's frozen archive thus becomes a tool for understanding not only its own history, but the broader dynamics of Earth's climate. It is both record and lesson, evidence and insight. Finally, contemplating Antarctica's ice teaches us about perspective. The continent reminds us that what appears static is actually dynamic. Glaciers move, ice sheets grow and shrink, and hidden ecosystems persist or vanish. Fossils, chemical signatures, and biological remnants provide glimpses into deep time, yet the majority of the continent's history is concealed. Patience, careful observation, and a respect for scale required to appreciate the delicate balance between preservation and erasure. In this quiet, measured way, Antarctica reveals itself as a continent of contrasts. Ice preserves yet destroys. Subglacial lakes harbor life yet remain hidden. Mountains shape climate, yet are concealed beneath kilometers of frozen stone. Fossils tell stories, yet only fragments endure. The continent invites reflection on endurance, impermanence, and the subtle persistence of life and memory over geological time. As we conclude this part, it is worth remembering that Antarctica's story is ongoing. Each ice core drilled, each radar survey completed, each sediment sample analyzed adds to our understanding of this hidden continent. Yet much remains unknown. Its glaciers, lakes, and mountains continue to shape and conceal, offering fragments of memory while erasing others. Antarctica is a lesson in patience, observation, and humility, a place where deep time is written in ice and life endures, quietly beneath the surface. Beneath the ice, beneath the stillness, lies a record older than most of the life we see today. Antarctica is not simply a frozen land. It is the product of immense forces that have shaped and reshaped the continent over hundreds of millions of years. The slow drift of tectonic plates, the collision and separation of continents, and the grinding of glaciers across hidden mountains tell a story of creation, transformation, and persistence. Antarctica was once connected to other continents as part of Gondwana, the great supercontinent that included South America, Africa, India, and Australia. During this time, Antarctica occupied a much warmer latitude, supporting forests, rivers, and life of all kinds. The fossil record, sparse though it is, speaks to this lush past. Ferns, conifers, and flowering plants once thrived, while dinosaurs and early mammals roamed the land. The continent's life was interconnected with neighboring continents, linked through land bridges and shared ecosystems. Over millions of years, tectonic forces began to reshape this world. Gondwana slowly broke apart. Antarctica drifted southward, isolating itself from other landmasses. Oceans opened and closed. Mountain ranges were uplifted as continents collided. Valleys formed, eroded, and were eventually buried under glaciers. These geological shifts were slow, imperceptible in human lifetimes, yet profound in their consequences. The drift southward gradually transformed Antarctica's climate, cooling it over millions of years, and eventually leading to the dominance of ice. The movement of tectonic plates also created hidden landscapes beneath the ice. Mountain ranges like the Gambutsov, completely concealed, are the remnants of ancient orogenies, the slow building of mountains through tectonic collision. Valleys and basins formed as the crust bent and fractured, later filled by sediments and, eventually, by ice. These mountains, buried but not erased, influence ice flow even today. Their contours shape glaciers, subglacial lakes, and hidden rivers, guiding water and ice in patterns that have persisted for millions of years. Antarctica's tectonic history also shaped its role in global climate. As the continent drifted south, it became isolated by the formation of the Southern Ocean. Ocean currents shifted, carrying cold water around Antarctica and contributing to the growth of ice sheets. The continent's position at the pole created conditions for glaciation, altering sea levels, climate patterns, and global ecosystems. The ice that dominates the continent today is a direct consequence of these geological movements, a reminder that land, water, and life are intertwined over immense spans of time. The continent's bedrock itself tells a story of endurance and transformation. Beneath the ice, ancient rocks reveal multiple cycles of erosion, uplift, and sedimentation. These rocks are archives of deep time, preserving chemical signatures, fossils, and textures that speak of conditions long vanished. By studying them, scientists can reconstruct the environment, climate, and even the biological communities that once flourished. Antarctica's bedrock is both witness and participant in the planet's ongoing story, shaped by forces both violent and gradual. Glaciers, moving atop this bedrock, create another layer of preservation and erasure. Ice sheets advance, grinding valleys, smoothing mountains, and carrying sediments across vast distances. Subglacial rivers flow quietly beneath kilometers of ice, redistributing water, minerals, and traces of life. Subglacial lakes, sealed from the atmosphere, preserve ecosystems isolated for millions of years. Antarctica's ice is simultaneously destructive and protective, erasing some evidence while safeguarding other fragments for discovery. The tectonic past also frames the fossil record. As Antarctica moved southward and cooled, ecosystems shifted, forests shrank, rivers dried, and animals migrated or perished. Fossils that remain are rare and precious, preserved in sedimentary layers protected by rock or ice. The very movement of the continent determines what evidence survives today. Ice cores, sediments, and fossils together tell a story of life adapting to change, of landscapes reshaped by forces far beyond human perception. The continent's hidden lakes and mountains owe their existence to tectonic processes. Subglacial lakes collect in basins carved by ancient faults. Hidden mountains influence ice flow, creating channels and barriers beneath the ice. These features, though concealed, are essential for understanding how the continent operates today. They are examples of a world shaped by immense, slow forces, reminding us that what is visible at the surface is only a small part of a much larger story. The slow dance of tectonics also connects Antarctica to the larger planet. The opening of the Southern Ocean, the drift southward, and the uplift of mountains have influenced global climate, ocean currents, and biodiversity. Life adapted elsewhere, responding to changes in temperature, sea level, and atmospheric composition. Antarctica, though isolated and extreme, is part of a planetary system, its movements felt across oceans, climates, and continents. Reflecting on these processes brings a sense of scale and patience. Antarctica's transformation unfolded over millions of years, slow and steady, often imperceptible except to those who measure and observe carefully. Ice, rock, and life interacted continuously. Valleys filled, mountains rose and eroded, forests vanished, and microbes endured in isolated lakes. The continent is a testament to endurance, to the quiet persistence of natural forces that shape life and landscape alike. This deep perspective also invites subtle reflection on human presence. In the span of a few centuries, humans have arrived at the edge of Antarctica, studied its ice, drilled cores, and mapped its hidden landscapes. Yet in geological terms, our presence is fleeting. The forces that sculpted this continent operate on scales far beyond human lifetimes. Antarctica's history teaches humility, patience, and reverence for the slow, persistent processes that govern the planet. Even the erasure caused by ice and tectonics carries meaning. Erosion removes forests, rivers, and sediments, yet also creates conditions for preservation. Subglacial lakes remain untouched, fossils survive in rare pockets. Chemical signatures endure in ice layers. The interplay of destruction and preservation shapes what we can know, what we can imagine, and what remains hidden. Antarctica's story is never fully revealed, but fragments offer profound insight into a world beyond immediate perception. By studying Antarctica's tectonic history, we begin to appreciate the complex forces shaping all continents. Mountains rise and fall, oceans open and close, climates shift, and ecosystems respond. Antarctica is a unique laboratory, but it is also a mirror reflecting the processes that have shaped Earth's other continents. Its ice, lakes, mountains, and fossils are records of transformation, endurance, and adaptation. Each discovery, each measurement, is a reminder of the subtle, ongoing interactions between life, land, and climate. The hidden world beneath Antarctica's ice is also a world of resilience. Microbial life endures in lakes sealed for millions of years. Fossils preserve fragments of forests and rivers long vanished. Mountains guide glaciers and influence the distribution of ice. Valleys carved by tectonic forces hold sediments that preserve chemical and biological traces. Antarctica demonstrates that life, land, and ice are intertwined, enduring and evolving even under extreme conditions. As we reflect on this tectonic past, it is clear that Antarctica's story is a slow, continuous narrative of change, adaptation, and endurance. Glaciers move silently, ice sheets advance and retreat, and hidden ecosystems persist in isolation. Fossils, chemical signatures, and sediments tell the story of life and climate responding to forces beyond human control. The continent reminds us that time is vast, that memory is fragile, and that the planet preserves fragments of history even as it erases the majority. In contemplating Antarctica's tectonic history, one begins to sense the patience required to understand the continent. Every valley, mountain, subglacial lake, and sediment layer is evidence of processes that unfold over millions of years. To study them is to align oneself with deep time, to observe patiently, and to respect the subtle forces that shape both landscapes and life. Antarctica teaches observation, humility, and reverence for processes far larger than human lifetimes. The continent's hidden landscapes also inspire quiet wonder. Subglacial lakes seal ecosystems from light and wind. Buried mountains influence ice and water flow. Fossils speak of life long vanished, yet their presence reminds us of endurance. Ice preserves what is fragile and erases what is transient. Antarctica is a world of subtle contrasts, a place where memory persists and yet much is concealed. Its story is recorded in layers, fragments, and chemical signatures, waiting for careful interpretation. Through this lens, Antarctica is both archive and mystery. It is a continent shaped by tectonic forces, ice, and climate over millions of years. Its hidden mountains, lakes, and sediments hold evidence of life and change. Its glaciers erase and preserve simultaneously. The story of Antarctica is ongoing, unfolding silently beneath kilometers of ice. By studying it, we glimpse the interplay between life, land, and time, gaining insight into processes that operate far beyond human perception. In this reflection, one can appreciate Antarctica not merely as ice or rock, but as a chronicle of endurance and transformation. Tectonic forces sculpted the land, ice reshaped it, life adapted or vanished, and fragments of memory remain for us to study. The continent teaches patience, observation, and respect for deep time. It reminds us that history, life, and memory are fragile, often hidden, yet enduring in subtle, extraordinary ways. Beneath the seemingly still surface of Antarctica, water flows quietly, shaping the land in ways invisible to the eye. Subglacial rivers, hidden under kilometers of ice, trace their courses through valleys carved by ancient tectonics. These rivers carry sediments, minerals, and sometimes even life, slowly moving across landscapes that have been sealed from sunlight and wind for millions of years. To contemplate their existence is to witness a hidden, patient world, a silent choreography of ice and water. The discovery of subglacial rivers has transformed our understanding of Antarctica. Once thought to be a static, frozen desert, the continent is now recognized as dynamic, with hidden hydrological networks that influence ice flow, sediment distribution, and even local ecosystems. These rivers are not vast torrents, but subtle, steady flows that move beneath the ice, guided by gravity, topography, and the pressure of overlying glaciers. They are quiet, yet persistent forces, shaping landscapes in ways both destructive and preservative. Subglacial rivers carry sediments eroded from bedrock and mountain ranges. These sediments are ground finely by the immense weight of glaciers, creating a slurry that flows slowly but relentlessly. Over millennia, these rivers carve channels, fill basins, and redistribute minerals. The process is gradual and often imperceptible, yet its impact is profound. Valleys deepen, basins form, and lakes are maintained or drained, all under the ice, hidden from direct observation. One of the most remarkable aspects of these rivers is their role in preserving life and chemical evidence. Microbial communities, adapted to darkness, pressure, and cold, survive in water that has been isolated for millions of years. Sediments carry traces of ancient environments, capturing chemical signatures of past climates. In this way, subglacial rivers are both sculptors of the land and archivists of history, recording the subtle interplay of geology, water, and life over vast timescales. The movement of ice above these rivers adds another layer of complexity. Glaciers are not static, they creep, flow, and deform under their own weight. Ice sheets mold themselves around subglacial topography, influencing the speed and direction of flow. In turn, the rivers beneath guide the ice, lubricating its base and shaping glacial movement. It is a dance of forces, slow and imperceptible yet profoundly influential, linking water, rock, and ice in a delicate balance that has persisted for millions of years. Scientists study these hidden rivers using radar, seismic imaging, and other indirect methods. By mapping the contours of the bedrock and the flow of water, they reconstruct the dynamics of subglacial hydrology. Each discovery reveals unexpected complexity. Lakes connected by networks of rivers, channels carved through ancient mountains, and sediment deposits that record the history of movement beneath the ice. These hidden waterways are like veins in a frozen body, vital yet concealed, carrying the lifeblood of geological processes. The presence of subglacial rivers also highlights the interplay of preservation and erosion. Water erodes rock and sediment, even as it preserves chemical and biological traces. Fossils may be ground down or transported, yet chemical signatures remain embedded in sediments. Life persists in isolated pockets, adapted to conditions humans can barely imagine. Antarctica's rivers, hidden from view, demonstrate that even in extreme conditions, processes of destruction and preservation operate simultaneously, shaping landscapes and recording history in subtle ways. Subglacial lakes, often connected to these rivers, provide still further insight. Lake Willans, for example, hosts microbial life that survives in complete darkness, fed by chemical energy other than sunlight. Sediments at the lake bottom capture materials eroded from mountains above, including minerals, organic matter, and chemical traces. These lakes are pockets of both preservation and isolation, ecosystems that endure in darkness, insulated from the surface, yet intimately connected to the movement of water beneath ice. The scale of time involved in these processes is staggering. Rivers flow beneath ice at rates often measured in centimeters per day. Yet over thousands or millions of years, these slow flows carve valleys, deposit sediments, and shape subglacial landscapes. Glaciers above move in tandem, grinding bedrock and transporting debris. Their slow, relentless motion intertwining with the hidden rivers. The result is a landscape continually formed and reformed, both ancient and dynamically alive. Subglacial hydrology also informs our understanding of ice sheet stability. Water beneath the ice can influence glacial speed and movement, affecting ice loss and sea level rise. The study of hidden rivers is therefore not only an exploration of history, but a vital tool for predicting the future. By understanding how water interacts with ice and bedrock, scientists gain insight into the continent's behavior and its broader impact on global climate systems. Reflecting on these hidden flows, one begins to appreciate the subtle power of persistence. Water, though invisible beneath the ice, shapes mountains, valleys, and sediments. Microbes survive in isolation, tracing chemical pathways through millions of years. Ice responds slowly, but inevitably to the presence of water, gliding over bedrock and redistributing material. Antarctica's subglacial rivers are patient sculptors, demonstrating that even the quietest forces can shape the world profoundly over deep time. The contrast between visible and hidden features is striking. On the surface, Antarctica appears static, cold, and barren. Yet beneath the ice, rivers flow, lakes harbor life, and mountains guide glaciers. Evidence of ancient ecosystems is preserved in sediments carried along by these waterways. Fossils and chemical traces endure, concealed but accessible through patient study. Antarctica is a continent of contrasts, frozen yet dynamic, silent yet alive, concealed yet revealing fragments of history. The existence of these rivers also invites reflection on scale. Human perception of time and motion is limited. A river flowing beneath ice at centimeters per day seems immobile, almost imperceptible. Yet in the context of millions of years, these flows carve valleys, redistribute sediments, and influence glacial movement. The scale of Antarctic processes stretches beyond human intuition, offering a perspective of patience, endurance, and quiet transformation. Moreover, subglacial rivers are a reminder of interconnectedness. Water moves beneath mountains and glaciers, connecting lakes, sediments, and ecosystems. Chemical signatures trace the movement of minerals and life across hidden landscapes. Glacial flow responds to these rivers, while ice influences water distribution. The continent operates as a network of interconnected systems, a delicate balance of preservation, erosion, and life, functioning quietly beneath a frozen surface. Contemplating these hidden rivers also invites subtle awe. Life endures where sunlight does not reach. Sediments carry stories of climates long past. Water flows silently beneath glaciers that have persisted for millions of years. Mountains, buried and concealed, guide the movement of ice and rivers alike. Antarctica is alive in ways invisible, a testament to the persistence of natural forces and the quiet endurance of life in extreme conditions. These hidden waterways further illustrate the interplay between visibility and mystery. Much of Antarctica remains beyond direct observation. Instruments reveal patterns, but the majority of rivers, lakes, and landscapes remain concealed. Their influence is measurable, yet their full nature is unknown. The continent teaches patience and humility, reminding us that knowledge often emerges gradually, in fragments, and that the most extraordinary processes may occur quietly, unseen by human eyes. Finally, subglacial rivers highlight the continuity of history. Ice, water, and rock interact over millions of years, preserving traces while erasing others. Microbial life persists, sediments carry chemical signatures, and glaciers shape hidden valleys. The continent's hidden flows connect the past to the present, linking ancient ecosystems to modern scientific discovery. Antarctica's rivers remind us that even the quietest, slowest forces have profound impacts over time, shaping landscapes, preserving memory, and revealing subtle stories of endurance and change. In reflecting on these hidden rivers, one gains a sense of Antarctica as a living archive. Its ice is not inert, its waters move, its mountains influence, life persists. Each subglacial lake, channel, and sediment layer contributes to a story of endurance, transformation, and quiet persistence. Antarctica is a continent that conceals yet reveals, erases yet preserves, offering fragments of its history to those who study patiently and observe with care. The quiet flow of subglacial rivers invites contemplation of both time and resilience. Forces operate slowly yet decisively, shaping landscapes, guiding glaciers, and preserving traces of life. The continent reminds us that the most profound processes are often hidden, and that understanding requires patience, observation, and reverence for scales beyond human experience. In Antarctica, water flows silently beneath ice, carrying with it both history and life, shaping a hidden world that endures despite the passage of millions of years. Beneath kilometers of ice, hidden from sunlight and wind, Antarctica conceals a network of subglacial lakes. These lakes are sealed off from the surface, isolated for millions of years, and yet within them, life persists. Microbial communities survive in extreme conditions, nourished by chemical energy rather than light, adapting to pressures, cold, and isolation. These lakes are fragile time capsules, preserving both biological and chemical traces of a world long hidden beneath ice. One of the most studied of these lakes is Lake Vostok, buried beneath nearly 4 kilometers of ice. For decades, it remained a mystery, known only through radar and seismic surveys. Scientists predicted it might contain life, isolated from the atmosphere for tens of millions of years. When samples were eventually retrieved, they revealed microbial life that had adapted to a world without sunlight. These organisms survive on chemical reactions within the lake, using minerals and gases trapped for eons. Their existence challenges our understanding of life's persistence in extreme isolation. Subglacial lakes are not merely reservoirs of water, they are living archives. Sediments at the lake bottom capture chemical signatures, traces of erosion from surrounding mountains, and even remnants of ancient ecosystems. Each layer of sediment tells a story of flow, freezing, melting, and chemical processes over geological time. These lakes are archives of both biology and geology, preserving information about the continent's history and the endurance of life under extraordinary circumstances. The isolation of subglacial lakes makes them laboratories of evolution in miniature. Microbes adapt to the slow accumulation of nutrients, the pressure of overlying ice, and limited energy sources. These ecosystems are extremely stable, yet incredibly fragile. Changes in water chemistry or temperature could have profound consequences, even millions of years after isolation began. In this sense, the lakes are not static, they are dynamic worlds, evolving silently beneath the ice. Sediments within subglacial lakes also preserve evidence of past climates. Chemical isotopes reveal temperatures, precipitation patterns, and interactions between ice and water over time. Minerals eroded from ancient mountains tell a story of tectonic activity and glacial movement. Even microscopic organic remains hint at the ecosystems that existed before glaciation. These layers are subtle, often invisible without careful analysis, yet they hold information essential for reconstructing Antarctica's deep past. The lakes are interconnected in hidden networks. Subglacial rivers carry water between them, transporting sediments, chemicals, and even microbial life. This flow is slow but persistent, creating pathways that shape both ice and bedrock. Glaciers above respond to these movements, adjusting flow rates and exerting pressure on the landscape below. In this way, Antarctica's hidden hydrology is a system of interdependent forces where ice, water, and life influence each other over millions of years. The microbial life in these lakes is extraordinary, not solely for its resilience, but also for its diversity. Though isolated, communities display surprising complexity. They interact with their environment in subtle ways, processing minerals, producing gases, and sustaining ecological cycles in a frozen darkness. Each discovery expands our understanding of the limits of life, demonstrating that even in extreme isolation, organisms find ways to endure and adapt. Subglacial lakes also preserve traces of Earth's history beyond biology. Chemical compounds trapped in sediments and water provide information about atmospheric composition, volcanic activity, and even distant ocean currents. These lakes are repositories of memory, capturing interactions between the continent, oceans, and atmosphere over millions of years. In studying them, scientists access fragments of a world that predates human observation by millennia. The physical isolation of the lakes mirrors the fragility of preservation. Just as glaciers erode valleys and subglacial rivers redistribute sediments, disturbances in these lakes could erase long-standing records. Yet the very isolation that makes them vulnerable also protects them from surface changes. They are insulated archives, simultaneously fragile and enduring, demonstrating the delicate balance between preservation and loss in Antarctica. Antarctica's hidden lakes also challenge perceptions of permanence. Ice sheets advance and retreat, glaciers grind bedrock, and subglacial rivers flow unpredictably. Within this dynamic environment, lakes maintain stability over millions of years, yet the landscape around them is continually reshaped. Their persistence is remarkable, a testament to the subtle balance of forces that maintain these ecosystems while the world above changes relentlessly. The chemical signatures in these lakes reveal subtle interactions with surrounding rock. Minerals leached from bedrock provide nutrients, while gases trapped in sediments offer insight into ancient atmospheric conditions. Microbes exploit these chemical gradients, transforming their environment while leaving traces of their activity in sediments. The lakes are therefore both shaped by and shapers of life, a dynamic interplay between biology and geology that has endured quietly beneath the ice. Some lakes contain sediments dating back tens of millions of years, providing snapshots of conditions before the current ice sheets formed. These records allow scientists to reconstruct past climates, glacial movements, and even tectonic events. Fossilized microbial mats and chemical traces hint at life that existed in warmer, more temperate times. Antarctica's lakes are windows into both deep geological time and the slow evolution of ecosystems, preserved in isolation, linked to the broader history of the continent. Reflecting on subglacial lakes invites contemplation of patience and scale. Processes that take centuries or millennia are invisible to human eyes, yet they shape ecosystems, sediments, and the flow of ice. Microbes persist in darkness, lakes endure beneath kilometers of ice, and hidden rivers slowly move sediments across valleys carved millions of years ago. Antarctica teaches that time operates differently in extremes, where persistence and subtle change define the rhythm of the land. The interplay of ice, water, and life in these lakes also reminds us that preservation is always selective. Some records survive, while others are lost to erosion, chemical alteration, or physical disturbance. The lakes preserve fragments of ecosystems, chemical compositions, and geological events, yet the broader context often remains hidden. Antarctica's hidden waters are therefore partial archives, offering glimpses of a world largely concealed beneath ice, demanding careful interpretation and reverence for the scales involved. In contemplating these subglacial ecosystems, one begins to sense the quiet resilience of life. Microbes endure where sunlight cannot penetrate, chemical cycles continue where energy is scarce, and subtle ecological interactions persist beneath ice sheets that dominate the landscape above. Life's persistence is a quiet, patient phenomenon, unfolding on scales far longer than human lifetimes. Antarctica preserves these examples of endurance, offering lessons in adaptation, resilience, and the persistence of memory in extreme conditions. Subglacial lakes are also a testament to interconnectedness. Water, ice, rock, and life interact in subtle ways, each influencing the other. Glaciers respond to the flow of water, sediments shape chemical gradients, and microbial activity subtly alters local chemistry. The continent functions as a vast, slow-moving system, where even the hidden and isolated plays a role in shaping the visible world. Antarctica is a reminder that no part of the Earth exists in isolation. Even the most hidden ecosystems are intertwined with larger planetary processes. Finally, these hidden lakes evoke wonder and humility. They preserve life and history in a landscape dominated by ice, reminding us that even in the harshest conditions, persistence is possible. Each discovery, whether microbial, chemical, or geological, offers a glimpse into processes operating over millions of years. Antarctica's subglacial lakes are archives of endurance, evidence that the planet's history is recorded not only in rocks and ice, but in the life that persists quietly, patiently, beneath the surface. In observing the lakes, one recognizes the balance between concealment and revelation. Evidence is preserved, yet much remains hidden. Life endures in isolated pockets, sediments capture chemical traces, and ice moves above, constantly reshaping the landscape. Antarctica is a continent of contrasts, still yet dynamic, hidden yet revealing, frozen yet alive. Its story is written in water, ice, and life, slowly and quietly, waiting for those patient enough to read it. Subglacial lakes thus serve as both laboratory and archive. They are living ecosystems, chemical recorders, and geological witnesses, preserved by isolation yet continually influenced by slow processes of ice and sediment movement. They remind us that even in apparent stillness, Antarctica is alive, its landscapes and ecosystems shaped by time, pressure, and persistence. Every layer of sediment, every microbial mat, every chemical signature is a fragment of deep time, offering insight into a world that has endured far longer than human memory. In contemplating Antarctica's hidden lakes, one gains a sense of scale, endurance, and patience. Glaciers advance and retreat, ice flows slowly, water moves beneath the surface, and life adapts in silence. The continent's story unfolds on timescales difficult to comprehend, yet every fragment, every chemical signal, every living organism contributes to a continuous narrative. Antarctica is a testament to the subtle power of preservation, the quiet persistence of life, and the resilience of natural systems across geological time. The continent of Antarctica, though cloaked in ice and silence, is not static. Beneath the frozen expanse, layers of ice, water, and rock interact in a complex and subtle choreography, recording a history that predates human observation by millions of years. Subglacial rivers carve paths through valleys shaped by tectonic forces, lakes preserve isolated ecosystems, and glaciers respond to both. The continent operates as a network of interlinked systems, each component shaping and being shaped by the others. Ice, though seemingly immobile, moves continuously. The immense weight of glaciers presses downward, flowing slowly over the bedrock and shaping the underlying landscape. Mountains and valleys beneath the ice influence these movements, directing flow, accelerating ice in some regions and slowing it in others. The interactions between ice and rock are ongoing, a dynamic process that silently reshapes the continent. Glacial grinding sculpts valleys, transports sediments, and contributes to the redistribution of chemical and biological material across the landscape. Subglacial water acts as both facilitator and recorder of change. Rivers beneath the ice lubricate the base of glaciers, allowing them to move more readily while carrying sediments along hidden channels. Lakes beneath the ice preserve evidence of both life and climate, capturing chemical and microbial traces over millions of years. The interaction between water and ice is delicate yet persistent, guiding glaciers in ways that affect surface features and influencing the broader hydrological system beneath the ice sheet. Tectonic activity remains a quiet, persistent force, shaping the hidden landscape beneath kilometers of ice. Ancient faults and folds guide the course of subglacial rivers and lakes, influencing the distribution of water and sediments. Uplifted mountains, though buried, affect ice flow and water movement, demonstrating the deep connection between geological processes and hydrology. Antarctica is a landscape carved by both slow, steady movement and episodic geological events, each leaving traces that can be studied if one knows where to look. The interplay of ice, water, and tectonics also preserves fragments of ancient life. Microbes thrive in subglacial lakes, adapted to extreme conditions. Sediments carry chemical signatures of past climates and ecosystems, remnants of a time before ice dominated the continent. Fossilized plant and microbial material, though rare, offers clues about pre-glacial environments. Antarctica is thus both a site of preservation and erasure, a place where some evidence of life endures even as much is hidden or destroyed by glacial motion. The slow rhythms of glacial movement provide a sense of scale beyond human comprehension. Ice flows mere centimeters to meters per day, yet over centuries and millennia, these movements carve valleys, grind mountains, and redistribute sediment. Subglacial water shapes paths and maintains lakes, influencing ice movement in turn. In this way, Antarctica demonstrates the cumulative effect of small, continuous forces illustrating how time and persistence are essential components of change on a planetary scale. Antarctica's hidden systems also reveal interactions between the continents and global processes. Subglacial rivers and lakes influence ice sheet stability, affecting sea level and ocean circulation. The isolation of lakes preserves biological and chemical records that inform our understanding of Earth's past climate. The continent acts as both a recorder and participant in planetary systems, linking local processes to global consequences in ways that are subtle but profound. Chemical and isotopic analysis of sediments from beneath the ice provides additional insight. Minerals eroded from bedrock, transported by rivers, and deposited in lakes capture a record of tectonic activity, glacial movement, and environmental change. Gas concentrations in trapped bubbles reveal shifts in atmospheric composition, linking Antarctica to broader patterns of climate evolution. The continent preserves these traces, often concealed beneath ice, but available to those patient and careful enough to uncover them. The dynamics of subglacial ecosystems also highlight the resilience of life. Microbes survive in isolation for millions of years, feeding on chemical energy harder than sunlight. They adapt to pressure, cold, and nutrient scarcity, providing insight into the limits of life on Earth. These organisms demonstrate that ecosystems can persist in extreme isolation, subtly influencing the environment through biochemical processes. Antarctica is thus not merely a frozen desert, but a living archive of adaptation and endurance. Ice, water, and rock interact in ways that continually reshape the continent. Glaciers respond to underlying topography, while subglacial rivers and lakes adjust to changes in ice pressure and flow. Sediments are transported, deposited, and preserved, carrying both geological and biological information. Even small shifts in temperature or ice thickness can alter these interactions, revealing the sensitivity and interconnectedness of Antarctica's hidden systems. Tectonic history continues to influence these processes. Ancient mountain ranges, fault lines, and folds guide water and ice flow. Erosion by glaciers shapes valleys, influencing subglacial hydrology and sediment deposition. The combined effect of these forces produces a hidden landscape that is dynamic, interdependent, and profoundly intricate. The continent's story unfolds over millions of years, often invisible to human eyes, yet recorded in ice, water, and sediment. Antarctica's hidden features also reveal the balance between destruction and preservation. Glaciers grind rock and transport sediments, erasing evidence in some places while preserving it in others. Lakes and rivers maintain chemical and biological records even under extreme isolation. Fossils survive in rare pockets, chemical signatures persist for millennia, and microbial life endures. The continent demonstrates the dual nature of preservation, where some traces survive while others vanish, shaped by forces both subtle and immense. Reflecting on Antarctica's hidden processes inspires a sense of scale, patience, and humility. Subglacial rivers carve paths at imperceptible rates, ice sheets flow slowly yet inexorably, and tectonic forces operate over millions of years. Life persists quietly, often hidden, and evidence of past climates and ecosystems is partial but profound. The continent reminds us that understanding requires attention, care, and a willingness to appreciate processes beyond immediate perception. The interconnection between ice, water, and tectonics also highlights how subtle processes influence larger systems. Glacial flow affects subglacial hydrology, which in turn shapes ice movement and sediment distribution. Microbial activity alters chemical composition, while bedrock and mountain topography guide water and ice. Antarctica is a network of interdependent forces, demonstrating the complex interplay of life, geology, and hydrology over deep time. These interactions also offer insight into Earth's broader history. Sediments and chemical signatures preserved beneath ice provide evidence of ancient climates, tectonic events, and pre-glacial ecosystems. Subglacial lakes and rivers serve as archives of both biological and geological processes. Studying these hidden systems allows scientists to reconstruct the past, revealing the subtle forces that shaped Antarctica long before humans arrived. The persistence of hidden ecosystems highlights the resilience of life in extreme environments. Microbes adapt to limited energy, pressure, and cold, maintaining ecological processes over millions of years. These isolated communities illustrate the delicate balance of survival in extreme conditions, demonstrating that life can endure where conditions are harsh and resources scarce. Antarctica's hidden ecosystems are a testament to both persistence and adaptation. Glaciers, rivers, and lakes operate on scales that challenge human perception. The slow movement of ice, the gradual flow of subglacial rivers, and the isolation of lakes all reveal processes that unfold over millennia. The continent teaches patience and attention to detail, reminding us that significant change often occurs quietly and imperceptibly. Antarctica's hidden interactions emphasize that time is both scale and lens, providing context for understanding processes far larger than human experience. As we contemplate these hidden forces, we begin to see Antarctica as a continent of contrasts, frozen yet dynamic, concealed yet revealing, silent yet alive. Ice sheets and subglacial water, tectonic structures and sediments, microbial life and chemical signatures all exist in delicate balance, each influencing the other. The continent is a living archive, preserving fragments of history while continuing to evolve under the weight of time, pressure, and persistence. Antarctica also encourages reflection on impermanence. Glaciers erase valleys, sediments shift, and ice reshapes landscapes. Yet in this continual process of change, preservation occurs as well. Subglacial lakes safeguard microbial ecosystems and chemical records. Sediments carry evidence of past climates. Fossils endure in rare pockets. The continent teaches that preservation and destruction are intertwined, that even in extreme isolation, memory can persist. The hidden interactions beneath Antarctica's ice sheets offer lessons in patience, resilience, and observation. Life persists in isolation. Water flows beneath kilometers of ice, and tectonic and glacial forces interact to shape landscapes. The continent demonstrates that profound change can be quiet, subtle, and ongoing, and that understanding requires careful study, humility, and attention to the smallest traces of evidence. Finally, Antarctica's hidden systems remind us that the planet's story is written in layers of ice, water, and rock. Subglacial rivers carve valleys, lakes preserve ecosystems, glaciers grind mountains, and microbial life endures in isolation. Each of these processes contributes to a continuous narrative of change, adaptation, and preservation. The continent is both archive and laboratory, a hidden world revealing the intricate interplay of life, geology, and hydrology across deep time. As we reach the final layers of this journey, it becomes clear that Antarctica is far more than a frozen expanse at the edge of the world. Beneath the ice lies a landscape, both dynamic and patient, shaped by tectonic forces, carved by glaciers, and quietly nourished by hidden rivers. and subglacial lakes. Every layer, every sediment, every microbial mat tells a story of entrance, transformation, and subtle interaction, reminding us that even in isolation, history persists. The continent's mountains, buried beneath kilometers of ice, serve as anchors in the shifting ice sheets. They guide the flow of glaciers, influence the paths of subglacial rivers, and contribute to the formation of lakes. These hidden peaks, sculpted by tectonics and erosion, are not merely obstacles or inert features. They are active participants in the continent's evolution. The interaction of ice with rock shapes the surface above and preserves records of what has passed beneath. Subglacial rivers remain patient sculptors of this hidden world. They carry sediments eroded from bedrock, redistribute minerals, and sustain isolated ecosystems in lakes and channels. Over millions of years, these slow flows have carved valleys, filled basins, and maintained pathways through landscapes that were once warm and green. The rivers are subtle yet powerful agents of transformation, demonstrating that even forces invisible to the eye can shape continents profoundly over deep time. The lakes beneath the ice act as both archives and incubators. They preserve chemical signatures, sediments, and microbial life that reflect conditions long before the current ice sheets formed. Microbes persist in darkness and isolation, adapted to pressures and temperatures that would challenge most life forms. Their resilience provides insight into how life can endure in extreme conditions, and their chemical traces allow scientists to reconstruct environments, climates, and ecological interactions from millions of years ago. Chemical analyses reveal the intimate connections between ice, water, rock, and life. Minerals transported by rivers nourish microbial communities. Gas bubbles trapped in sediments record shifts in ancient atmospheres. Layers of sediment capture volcanic events, glacial advances, and subtle shifts in climate. Antarctica is, in essence, a repository of the planet's memory, preserving evidence of processes that shaped not only the continent, but also Earth's broader systems. Even tectonic forces, slow and often imperceptible, play a central role. Faults and folds beneath the ice guide rivers and lakes, shaping glacial flow and influencing sediment deposition. Mountains and valleys, formed and eroded over millions of years, dictate the patterns of water and ice. Antarctica's hidden landscapes are living records of the forces that have sculpted the planet, reminding us that change is continuous and often invisible, operating on scales beyond ordinary perception. The persistence of life in these isolated systems also invites reflection. Microbes thrive in subglacial lakes despite extreme cold, darkness, and nutrient scarcity. They exploit chemical energy to sustain themselves, leaving subtle traces of metabolic activity in sediments. These hidden communities demonstrate that life adapts, persists, and subtly transforms its environment, even in the harshest conditions. Antarctica, often imagined as barren, is in fact quietly alive beneath the ice. Glacial movement above these ecosystems is both destructive and preservative. Ice grinds rock and transports sediments, erasing some evidence of the past, yet simultaneously protecting lakes and microbial communities beneath kilometers of frozen water. This duality, destruction paired with preservation, is a constant theme in Antarctica's story. Erosion removes surface features, but isolation safeguards other layers of history, creating a delicate balance between loss and survival. The interplay of ice, water, and tectonics also speaks to the broader narrative of Earth's deep time. Antarctica is not an isolated outpost, but part of a planetary system, linked to oceans, climates, and ecosystems elsewhere. The continent's hidden features influence ice sheet stability, sea levels, and ocean circulation, demonstrating how local interactions can have global consequences. It is a reminder that even the most remote landscapes are connected to the larger story of the planet. Sediments and chemical signatures from subglacial lakes serve as keys to ancient climates and ecosystems. They reveal cycles of glaciation, patterns of volcanic activity, and the presence of life long before humans observed the continent. Fossilized microbial mats and mineral traces act as markers of persistence, signaling that life and memory endure even in extreme isolation. Antarctica is a landscape of both concealment and revelation, offering fragments of its past to those who study it patiently. The quiet, patient flow of subglacial rivers and the isolation of lakes provide lessons in resilience. Life adapts to extreme pressures, cold, and scarcity. Ice responds to subtle changes in topography and water flow. Sediments record the cumulative effects of millions of years of erosion and deposition. The continent's systems operate over scales far beyond human lifetimes, teaching us to appreciate the slow and subtle forces that shape Earth and sustain life in hidden corners. Reflecting on these processes offers perspective. Human presence on Antarctica is fleeting. Our research stations, aircraft, and instruments are temporary compared to the enduring glaciers, rivers, and lakes. Ice moves, water flows, and microbial life persists, largely indifferent to human observation. The continent reminds us that permanence is rare, and that the most enduring forces are often quiet, invisible, and patient. Antarctica's hidden history encourages curiosity without certainty. The evidence is partial, the ecosystems isolated, the sediment records incomplete. Yet the fragments we uncover allow glimpses into deep time, a planet that shifts, adapts, and preserves subtle memories. The continent is a living archive, a landscape shaped by ice, water, tectonics, and life, quietly preserving fragments of a history both extraordinary and elusive. The interactions beneath the ice also inspire a sense of humility. We witness processes that unfold over millions of years, movements imperceptible in a human lifetime, yet transformative over deep time. Antarctica teaches patience, observation, and reverence for subtlety. It reminds us that understanding the planet requires attention to detail, respect for scale, and a willingness to accept that some stories are only partially revealed. Even the hidden microbial ecosystems reflect broader truths about endurance. Life persists, adapts, and leaves traces, even when isolated from the wider world. Chemical signatures and sediments provide insight into the conditions that have persisted for millions of years. Antarctica demonstrates that memory, preservation, and adaptation are intertwined, and that even the quietest systems carry profound lessons about resilience and continuity. The continent's ice, water, rock, and life are all interconnected. Subglacial rivers shape valleys, lakes preserve microbial communities, and glaciers sculpt mountains. Chemical and biological traces link these elements, creating a network of subtle interactions. Antarctica operates as a system of balance, where forces act slowly yet decisively, and history is preserved even amidst ongoing change. As we consider these hidden networks, it becomes clear that Antarctica is both archive and active laboratory. Its ice, lakes, rivers, and sediments record Earth's history while continuing to evolve. Microbes persist in isolation, chemical traces endure in sediments, and glaciers shape landscapes. The continent teaches that understanding requires patience, careful observation, and a willingness to perceive processes unfolding beyond human timescales. Finally, in contemplating Antarctica's hidden world, we are invited to a quiet reflection. Ice and water preserve, erode, and transform. Life endures where it might seem impossible. Sediments and chemical traces carry evidence of deep history. Mountains guide ice and water, linking past and present. Antarctica is a testament to persistence, subtlety, and the entrance of memory are a world that appears silent, but is profoundly alive beneath the surface. If you have been quietly exploring these hidden landscapes with us, let this be a gentle invitation. Consider the patience, endurance, and subtle forces that shape not only Antarctica, but the world at large. Our journey into the depths of ice, water, and time reveals that even in isolation, life and memory persist. Antarctica's hidden ecosystems and dynamic processes remind us that history is often concealed, yet fragments remain for those willing to look. Thank you for joining this exploration. If you have felt a sense of wonder or reflection in this journey, consider subscribing or sharing your thoughts in the comments below. It is your presence and curiosity that keep these quiet stories alive. Rest now, letting your mind drift along the hidden rivers, beneath the ice, across time. Antarctica, in its quiet persistence, holds secrets that endure beyond the human span, a reminder of resilience, mystery, and the beauty of slow, patient processes. Good night, and may your dreams carry you gently through the frozen rivers, silent lakes, and enduring life of Earth's most hidden continent.